Welcome everybody to another episode of vBrownBag. We're here tonight with Vic Camacho and Voung Pham, and they're going to present vxRAIL vSAN encryption with HyTrust KeyControl. So the only thing that I will just tell you about vBrownBag is we have a lot of Twitter hashtags. We are regionalized. We launched our vBrownBag Brazil channel, which is pretty cool. You can always reach out with hashtag vBrownBag, and you can see our schedules there. Now I'm going to let each guest introduce themselves, and I'm going to pass over control to Voung. I guess you can start, Vic.
Oh, okay. Looks like Voung may not have audio. So hi, everyone. My name is Vic Camacho. I am the Strategic Solutions Architect with HYTRUST. Thanks for having us. And hello to all the vBrownBag crew. Certainly vxRAIL, thanks for having us and getting this set up for us. And it looks like Voung might be setting up the slide deck there, but are you back on, Voung?
Yeah, you can hear me now. Is that better?
Yes, absolutely. So I just introduced myself, and so I will pass this off to Voung.
Yeah, so my role currently is I'm a senior solutions architect for VMware, and I work in Sabu, and I'm product engineering, specifically storage availability business unit. My main product is vxRAIL, but today I'm not going to talk specifically about vxRAIL because this feature is not just for vxRAIL. This feature happens to be for vSAN, and I'm very lucky. I work with a great crew inside Sabu, and I've worked with Jason presenting to get this stuff together. So today we're going to be talking about decrypting vSAN encryption. That's a little bit funny, but we want to get everybody level set with vSAN encryption, help them understand some of the key terminology, and help everyone get better familiar with the technology and how it works. Does that make sense?
Sounds good. And I'll be taking any questions.
You guys still hear me?
Yes, sir. I'll be taking also any questions on the interface and through Twitter.
Great. Right. So what we're going to do is I'm very fortunate in the fact that I get to work with some great technologies and great people. But more importantly, this is a really hot topic, decrypting and encryption on vSAN. And we're going to go through the slide deck, and we're going to have some questions and a little bit of demo time. But at any point there are questions about what you're seeing or a question that comes to mind, please ask the question. If we can't get to them right away, we'll get them to you answered, okay? Here we go. So in vSphere 6.5, which is the current release, there's a lot of options for you to do encryption. You may have heard some of these, such as VM encryption or secure boot from virtual machines, or encrypted vMotion itself, or vSAN encryption. You can see from the deck in front of you that there are certain ways to do encryption in terms of what you want to encrypt and some advantages to each one. I'm not going to focus too much on each of those because I just wanted to give you an overview because I wanted to focus on vSAN encryption. Every particular encryption has a specific use case and pros and cons. So that's up to you to decide which one is best. For example, VM encryption is the hypervisor. So the big advantage there is that VM, that unit, and has no problem moving from storage to storage because it's portable. The encryption is portable. So then you look at secure boot, and what's really good about that is you're going to prevent any type of boot problems in regards to, is there a rootkit? Has this been compromised? So there's to go through when it comes and boots up with the EFI. The encrypted vMotion is pretty cool. I like that because, as you know, vMotion itself is open, but when you have an option to encrypt the vMotion from the endpoint, start point to the endpoint, and with a single use case, that's pretty awesome. So then our topic today is vSAN encryption, and there's another phrase for that. It's actually, there's a lot to know about that, and in order for us to level set, we need to discuss some of the key terms that are going to be used about this. So feel free to chime in anytime time, Vic, if I'm missing something or you wanted to add something to the conversation. Okay. So, some of the key terms we need to do here is like DEK. You might hear that option when people are having conversations about encryption. They're also going to hear about KEK, and they're going to hear about the KMIP server, also called the KMS or Key Manager Server. KMIP is just a protocol, and what's the current version now, Vic? It's version 1.1, I believe. Is that right?
That's if I'm not mistaken, that is correct. So KMIP 1. I believe it's 1.2, but I can look that up really quick. I always forget the numbers, the version that's out now. I believe it's 1.1.
Yeah. So what's really neat about that is it's an open standard and it's published, so people can use various KMS depending on your environment or various. Some people say, "Oh, I'm on a real tight budget. I need to use an open source one." You can do that, but you have to be careful about supportability and the full picture, what's going on here. So you're going to see for your data, encryption keys, and the bigger the key, generally speaking, the harder it is for decryption to occur, especially from a brute force perspective. Okay, so looking at this, what this is vSAN encryption is basically a common term people call that is data at rest encryption. You will protect against any sort of breach if the data is compromised. So you don't do the encryption in flight, but it's actually when it sits there. So it could be a post-process encryption, and that's what's really unique about this. So you can see the green would be indicating of the virtual machines that are encrypted, and the vSAN data store itself, you can see the big graphic there for the locks, and it's encrypted there. So it's really good. It's important for a lot of industries and how you're going to use that. So you need to understand that's what's good about that. So I'm not going to read the bullet points for you. They're pretty straightforward. Unauthorized access, that kind of thing. So that's good to know. So I'm going to leave her a couple seconds, and you'll see the recording. But going on, you can see here's the process overview. We said we want to talk about vSAN encryption, and there's basically 4 steps once you've set up the KMS. And in this environment, later in the demonstration, we use HyTrust KMS. It's just one of many that are supported, but it's one of the easier ones that I like to use. So you can see you add a KMS, you enter the IP address for that KMS server, you establish a trust relationship, and we will demonstrate that. And then you will also establish the trust between, oops, I got a typo there, establish trust between the KMS and establish with the ESX hosts. So sorry about that. So here it is. Here, this is the overview itself. Oh, sorry about that. So it's one click. The entire vSAN data store is encrypted as a whole. It's not, because remember vSAN is a distributed object store. So it's the whole single data store that is presented for all the participating hosts. So every object inside that data store is encrypted. And if you look at the way it's set up, you don't have to do anything for the guest. It's no modification. It doesn't care. And no access to the encryption keys. And that's important because, yeah. Do you have a question?
Sorry, Voung. There was a little bit of choppiness on the line, so guests or the attendees may not have caught that last line that you said.
Oh, okay. So the virtual machines are agnostic. Let me go back one up. And it doesn't matter what you have. But most importantly is in encryption mechanisms, the key, the encryption key, the guest OS have no access. They do not see the encryption key. They don't know what's going on. So that's important because if you lose the encryption key, there's potential for breach. Does that make sense?
Yep. And I do have a question. I do have a question from Graham. He says, "What's the difference between vSAN encryption and using SED drives?"
Okay. The big reason people don't like to use self-encrypted drives is really expensive. It's a cost measure, and it becomes very customized hardware. If you use an SED self-encrypting drive, you're going to limit yourself in terms of like a hardware. Now, why is that bad? Well, you have to think about agility in your environment. And if you have it at a software layer, you're part of the understanding that you're doing a software-defined storage, a software-defined data center, which will give you the advantage in your operations to be more flexible. There's a lot of responding to growth, responding to business change, and having that ability to respond quickly, agile, is what you really want in your operations. It's not like turning a dime corner with the Titanic or a large oil freighter. You don't want that. Does that make sense?
Yes. Thank you so much.
Yeah. Yep. Okay. So continuing on, we talked about encryption compatibility is important. I highlighted those things there. All flash, hybrid, doesn't matter for vSAN. You can use whichever model you want. You can use, dedupe encryption is available only over all flash. And the big thing is that the activation of encryption requires you to format your disk, your on-disk format. So that's going to take some time, and I'm giving you a heads-up warning about that. So if you think about it, you have an algorithm you're applying on top of your data store, and you want to make sure that it's complete, applied to the whole thing. Okay, so here's a overview set up. I'm going to show you this fancy slide. This slide deck came from VMworld, from Jace, and he was like, "Hey, go for it and show it people." And we want to get the word out, help people understand the vSAN encryption. This slide deck, the presentation, if you get a chance, I'll have the reference for you to download it and look for it. It's really good because it goes into a lot more other details. But tonight I wanted to focus on just the vSAN encryption. So once your KMS is set up, there it is. Your virtual center, you can have connection is between the KMS and the virtual center. And notice that the KMS is not on the virtual center itself, so they're separate entities. And you exchange the KEK, you exchange the cluster KEK ID, the host key is created on the KMS server itself. The connection is made, and then the key, once it's established, is pushed out to the shared secret. And then what I talked about, the format disk change across all the disk groups. Okay, and disk groups refers to the vSAN disk groups in each host. You're done. You're encrypted. That's the simplified version. Now you can see that in writes, what's going on from the cache layer down into the capacity tier. How the IOs are broken up, where the checksums are, things like that. So you're going to see that let me go past this real quick there. Yeah. So that's where the compression happens. That's where the size has the deep dive. So you're going to see that's how the mechanisms work behind the group, inside the disk group itself. Okay. So between the 4K chunks, the 64K chunks, the larger it is, the faster it goes through. So you can see that the IO is broken down. All right. So another operational consideration is that sometimes you need to rekey that because keys do expire. So if you need to rekey the encryption, there's certain levels of rekeying the data store, a shallow or deep key. As you can see, the impact is slightly different now, and that's something to know for operational purposes. The shallow rekey there's no impact as much as the deep rekey. Okay. Okay, so now I wanted to hit hard on this slide right here. This is very important. I'm not sure your role and your interest in this topic, but think about some design considerations that are very important. You don't want to make sure you hit these bullet points. Encryption, KMS, you don't want it on the same vSAN data store you're going to encrypt. That's not a good thing. It's complex, and you can lock yourself out if you lose the key, and it's just a bad operational complexity. Anything you want to say about that, Vic? Yeah, you want to add about that bullet item?
You're talking about the first one there. Yeah, you really don't need to encrypt your KMS, right? So if you lose the ability to get to your KMS, then the rest of your environment won't be able to get to it as well. And so how do you recover from that? You don't, right? So if you lose your KMS, for some reason, and you're not able to get to the KMS because it itself has been encrypted, there could be a potential that the rest of the VMs in the environment, those virtual workloads, won't be able to check those keys out, right? So it's best not to put that behind encrypted, so don't put it on anything that's going to be encrypted. That your KMS should be non-encrypted. It takes care of itself, it manages itself, and that's really important. You never want to be in a situation where the rest of your environment can't check out the keys so that the data is accessible, right? So just think of your KMS as the valet, right? At a parking, as an example. So if that valet box full of keys is gone, then nobody can get to their cars. Likewise, that's what the KMS here. So if you think about it that way, it's very important. And as you see more and more environments start to take data security into account, right? And by that, we mean encrypting the workload, then it makes sense to make sure that your KMS is not just not encrypted because of what we just mentioned, but also that you deploy it in a redundant manner. So always have at least a pair of KMS servers that are in sync with each other, so that if one KMS goes down, right, your key management server goes down, then you still have another one that can pick up the slack.
Yeah, well, I have a great diagram that's going to illustrate how that could work in theory. So then you could apply that to your. Okay. So on to the second. Thanks, Vic. Appreciate that extra input. The encryption itself, the CPU task, so it isn't intensive. So you need to be aware of sizing your environment accordingly if you're going to choose encryption. That's take. Overall, you know, as you add more features to the vSAN, you need to be sensitive to work balancing to make sure it's appropriate. The witness itself, if you're going to do a stretch cluster, there's some caveats to the stretch cluster design. And what does get encrypted, what does not get encrypted is important for a stretch cluster topology. And the last bullet point I wanted to talk about was the core dumps itself. Now that's the memory and the information in memory itself. If an ESX host does go down and you have a core dump, you need to make sure that you take care to where you place that. There's certain advanced configurations for ESX hosts that you output your core dump to a special location.
And
keys are in there. Okay?
Earlier on, we had a question that was asking about the overhead of software encryption, and I think this slide shows a lot about it. Do you have any numbers that you can say, here's a range that you can expect without AES NI and with AES?
No, I haven't done those numbers. I'd have to talk to the performance team. Have you seen those, Vic?
I've seen a couple, right? It's nothing that we have at HYTRUST, but we have done it with ours. We leverage AES NI as well, right? So that's the offloading of the encryption by using Intel's AES NI technology. Now they do have something that's coming that was just announced not too long ago. Intel now has this technology called Quick Assist that greatly improves on the performance of offloading all of that encryption. So, which is, I forget what the numbers came back at, but it's been published by Intel, and it far exceeds the capabilities of AES NI as far as offloading all of that workload. So your CPUs won't get taxed as much as anymore, right? They don't get taxed very much because of AES NI, but that's going to get a lot better now with Quick Assist. That's probably something for that is a topic that we can take on in another night, but that's already out, and we at HYTRUST, we are taking advantage of that as well. We're working closely with them.
Awesome, thank you.
So you can see that the topic of encryption is very very much in demand, and a lot of progress is being made in different directions, from efficiency and better performance and different methods to do that. Thanks, Vic. That's awesome. So yeah, so a little bit more about the core dumps. So when you have the core dumps, they might have the key. So here's some precautions that you should do about that. Use a password. The core dumps, the internal keys. So the bottom line is I want you to get from this slide is be careful. Be careful with your core dumps. That they're valuable information for your environment, and you shouldn't take it lightly. Okay. All right. Let's see. So some other operations to consider. Let's see here. This is Vic and I had a conversation about this morning. This is an important thing because to do the encryption for your vSphere environment for your vSAN, there's a special role that's used, and it's right there. It's called no crypto for your administrator. If you can see that it is similar to the administrator, but not quite exactly as the administrator role. But what's important is you can see what it does and does not do. Okay. So you still have that availability of security because there's no console access to the encrypted virtual machine. You're just encrypting it, but you're not allowed to see it. And later on, I have a resource at the end which tells you about how you can use open source tools to test for your encryption status. Okay, makes sense. You can see our vSphere administrator should know the role itself is always coupled with the privileges. So you may have a role, a title, what it does, but you need to see what privileges it can and cannot do. And that's good for you to audit. Okay, so I mentioned vSphere 6.5 has a lot of different types of encryption. And when you combine the VM encryption versus the vSAN encryption, there's various use cases. And you can see there's multi-tenancy if you want to keep them unique from each other. You want to have ability for storage mobility. We talked about that between different environments there. Virtual desktops, obviously like HIPAA controlled environments. Patient confidentiality is important for that. Compliance. And then deduplicate compression. Now be aware, and I'm going to say it point blank, VM encryption does not play well with compression and if your VM is encrypted at the VM level and you put it on a vSAN that is using deduplicate compression, it cannot take advantage of the deduplicate compression. That makes sense, Ariel? Vic, yeah, pretty clear?
No, you'll have to repeat it.
So what you're saying, Voung, and you broke up a little there. It sounded like you said that if the virtual machine is already using VM encryption, right, through vSphere 6.5 as an example, and then you move that into a vSAN cluster that already has encryption. That's kind of where I lost you. Were you saying that it wouldn't take advantage, or that you wouldn't get the full advantage of
deduplication and compression? Yeah, you wouldn't encrypt it twice. Number one, and number two, you wouldn't have the ability to do anything with object. So there's no advantage for you to use VM encryption and vSAN encryption if you want to use dedupe and compression. Yeah, that's not to say that you can't use it, but you can use it, but you're going to see some differences there. So if you have a VM and it's encrypted, that's great, and it's working perfect for you. You set it up. But if you try to put it into an all-flash vSAN that has deduplication and compression enabled, you're not going to see that able to take advantage of the deduplication and compression for that particular VM. Okay.
So then, would it make sense to then say something like, well, if you do have a virtual machine that's been encrypted already, would it make sense to unencrypt it and then move it into the vSAN environment to take full advantage of dedupe and compression? Oh, and by the way, it's already going to be encrypted because it's vSAN using encryption. Okay, that makes sense.
Yeah. So if you wanted to encrypt that virtual machine and take advantage of dedupe compression, then use just vSAN encryption. You'd have to change the storage policy on the VM itself because the VM storage policies leverage VM encryption leverages storage policy, and it changes that. So once you change the storage policy on the VM itself, it can be unencrypted, and then it would be able to take advantage of vSAN encryption and deduplication and compression.
Okay.
Make sense?
Makes sense.
Yeah, that's a big sticking point. So I want to make sure that gets hammered in a little bit. Okay.
Perfect. Thank you.
Perfect. Thank you, everyone. Okay, so you can see the multi-tenancy, the vSAN, you know, what's going on there, how you move around there. Okay. Okay, day two considerations. We talked about this, Ray, extensively with Nick. There's some good stuff there. You know, CPU speed, AES, NI. You know, so it's always the faster processor will have more advanced features for you to take advantage of encryption. You know, how much IO, how much DAO. You consider those things in terms of what's going to impact your day-to-day operations. You know, speed, bandwidth, protocol. The initial encryption is important because it's going to take a while. It's going to take a while to get encrypted, but after the fact, it's pretty much, you know, under the covers. You don't see much going on there. Okay. And understanding how the KMS and placement cluster. I'm going to look at on this bullet point right there, the last one. I want to show you a graphic which will help illustrate that a little bit better. So if you look at a single situation, you can see this is a single site. This is a repeating GIF here, so you can see, like what Vic mentioned, you do not want to have a single valet. I like that analogy. Holding a key master there is holding the key in the KMS. And if you have multiple KMS cluster scenario, then you're going to have a higher availability and less likely a chance of losing your key and losing your data. Okay. Then if you go to a situation where you want to go to a multi-site, then you want to use a larger cluster that has a high availability within the single site itself. So site A and site B have a spread cluster between the two, and you can see how it has higher availability within site and intra-site because they can rely on each other. Right there, it's spread across the way. And from VMworld, obviously, you can see that, and Mike Foley, security deep dives about KMS topology considerations. Again, the most important thing is to make sure you have high availability for your KMS, whatever vendor you choose. Choose a vendor that has been tested and approved for supportability. So that means, let's go back to this here. I want to make sure that we understand the placement for your KMS outside of the vSAN and the clustering and necessity for a production sensitive environments or any environment for the matter that's going to be using a vSAN encryption. Okay.
So Voung, if we can we go back one slide? Okay. I wanted to point out on the use case slide, right? Because VMware does offer vSphere encryption. They offer vSAN encryption, right? And so I think it's important for folks to understand that there are use cases for each one, right? So vSphere encryption, those are one-off VMs that are being encrypted, right? You can apply the encryption policy to a single VM or a multitude of VMs, right? And when you would use that, especially if you have VMs that are very mobile and portable, and they need to vMotion from one cluster to another cluster, right? So if you have stretched clusters, as an example. In the vSAN scenario, and correct me if I'm wrong here, but my understanding is that because the entire cluster is encrypted, if the virtual machine moves outside of the vSAN cluster, then it would be deep decrypted, right? Because it's moving outside of that cluster. So those VMs aren't as portable. They can certainly move around and vMotion around within the vSAN cluster. There's no impact there. But if those virtual machines do need to be more portable and maybe move across, right? So there are use cases, business use cases, where virtual machines do have to move.
You're right.
As an example, right, moving from a vSAN cluster.
Thank you for highlighting that. That's important.
Right. So a vSAN cluster on-prem, and let's say that virtual workload also has to move into the cloud, right, where you may or may not have vSAN up in the cloud. So, you know, that may not be a good candidate for vSAN. So VMware has the ability to meet both of those requirements. And then likewise, with the other part of that, if you do need multi-cloud, if you do have multi-cloud environments where you have on-prem and at least one cloud, or maybe two, then there are other ways of encrypting, right? And that's, you know, with the help of HYTRUST, obviously, but so there's use cases.
Well, that's the whole point. Understanding,
So now we have the ability to meet VMware customers' requirements across the board, right? And that's using, you know, vSphere and 6.5 and vSAN 6.6 Enterprise.
Exactly, and that's the whole point. I mean, you know, encryption is a big deal. No, you're 100% spot on, Vic. Encryption is a big deal. So there's different methodologies of encryption available in vSphere 6.5. So you have to understand your use case of what's going to be important for you. The mobility is a big deal for the virtual machines, and then you have the ability of having an entire efficiency for the vSAN itself, and it's simple. Again, if you're on a traditional array, you don't have necessarily the advanced features of data at rest encryption. So you want to take advantage of what you do have. And using the vSphere 6.5, you can simply, with a couple of clicks, encrypt your virtual machine at that level. And you're guaranteed some sort of safety net in case it gets compromised. Does that make sense? So yeah, 100%, you're right there, Vic. And it's good to draw that out. That the slide is a really busy slide, but having the understanding of the use cases for when you would want to use a VM encryption or when you'd want to use a vSAN encryption is very important. I focus on the dedupe and compression, but you know, Vic wanted to make sure everybody understood that the storage and mobility is important, of understanding, you know, when you would use it. And if you look at the traditional array itself, you want to understand that too. So those are some use cases, and it could be a deep dive conversation to make sure you use the right encryption for your environment. Okay.
Thank you,
so I'm going to switch over to a demo to show how encryption is going to work. We still have time?
Yes, sir. Take all the time you want.
All right. So just to summarize, before we close it up, ease of deployment, flexibility, your choice. We try to emphasize that. And it's bottom line, it's secure. So you can do what you want to do, how you want to set up your KMSs, and what environment, what vendor you want to use, how easy it is to use. For this demonstration, we use HyTrust because it's simple, it's easy, powerful, but you know, you may have a bit different vendor you like to use, and it's all compliant. That's the most important, and supported. So this is an important page. I want you to make sure you guys make note of that. VMware group in Cebu has some awesome things here going on, and so does the vSphere team at VMware. These are called the feature walkthroughs. These URLs are great. You want to know more about VM encryption, secure boot, encrypted vMotion, you know, and then you go through those walkthroughs. You'll figure out, they'll show you quickly at a high level how to use those features there. The fourth bullet item there, you can search to see which KMS is certified. And that's so important for supporting a production environment. You want to make sure you have the supportability to back you up. Because your vendor will take the time to test and validate with VMware to make sure everything works great. So another thing to consider also would be this sleuth kit. If you were to take an encrypted VMDK from the VM and try to load it onto that's been encrypted and try to attach it to another virtual machine, and you try to say now it's been compromised, you've copied it down and you think you have the data, but you'll see that with the sleuth kit, this open source sleuth kit, you can't see anything. The encryption makes sure you see nothing at all. You'll see that all the data is all scrambled up. Okay, that's important to know, that you can independently verify the encryption and test it and kick tires all you like, but you know, other people have done this already too, just to let you know how to do it right there. And this slide, Jason McCarty and Mike Foley, they did a great presentation at VMworld. We talked about a lot more than what we did here. They went to 3 different areas, you know, vSphere encryption, virtual machine encryption, and vSAN encryption. They talked about power CLI methodologies for validation and verification and implementation. They talked about all the steps involved with all the levels of encryption. I just wanted to focus a little bit more about the terms, use cases, and a little bit about vSAN encryption, so you can be more informed as a consumer, as an administrator, or as an architect in your environment, so you can have those good conversations that you need. Did you want to add anything on this before we go?
No.
Questions? Ariel?
Well, if there's any questions out there, it'd be a good time. But I have nothing. I think this is good. I think those links there will give folks a good view and a good understanding of 6.5, vSphere 6.5, the encryption, the encrypted vMotion. That's all important concepts to understand.
So one thing I did, Voung, I took a screenshot of that and I tweeted it out. But if you have a blog post or you can send me the links, I'll be happy to tweet them out and related to that session and put them in the show notes.
Oh, I'll find you.
Right.
I know that presentation is available to anybody who attended VMware World. All the sessions are recorded, and you can watch those two guys go at it and tell you all about the good stuff, encryption, and replay. And you can download that too, but I'll get you a link. Okay. Okay. Let's see questions. We're gonna leave it open there. I want to go switch over to the lab environment and show you guys something pretty cool. So I am still connected to my lab environment. It's here. Let me log in here. This is a 6.5 environment. It's in flux. There's a lot going on. I'm changing some stuff. But for today's demo, one of the key things we've already added is a single KMS server. And if you go to the vSphere administration web interface, you can see that from the VCSA, the focus you need to be, which I'm pointing to.
Hey,
Then from there, you need to
make
make sure you're on the configuration tab. Oh, so just reinforcing, you need to be where inside the vSphere web client. You need to be at the vCenter level itself, not at the data center level, not at the cluster level, but at the vCenter level itself. You go to configure, you're configuring the KMS for this particular vCenter, right there. So you can see we've added one already. And if we go to this cluster and we want to enable the properties for encryption, give me a second. We want to go to the cluster now, because some clusters can be unique, and this configuration is two separate vSAN data stores. Okay, so that's why we're able to do this. You can see the encryption is disabled. The vSAN general properties right here. So if you want to change that, you can just go to Edit and do encryption. You can see that the KMS is registered, and you just turn on encryption. Erase this is to ensure if there's anything on there originally you want to make sure. If you don't want to, you don't have to do that at all. It depends on your environment. It's greenfield or what have you. Okay. And reduce redundancy is depending on your environment. I currently have a greenfield environment, so that's not a concern. So if I click OK, you can see what it's going to do its thing. So if I go back down to task, you should see what's happening here. There you go. The formatting happens to version 5. Okay. Now that's going to take a while. It's going to do its thing. We're not going to watch it the whole thing, but it isn't. This isn't all flash vSAN, so it should be faster than other. And it's green filled, so there's less overhead for you to do that. So it has to go through each disk group and go through and apply the new disk formatting. Okay. Now here's what I talk about: encryption keys, the operations. If you want to do deep key or a shallow key, you use these options here. So from there, I want to go through and go back to this scenario. This is pretty cool.
Hey,
I mean, if you look at, yeah.
Hey, Voung, so really quick, back on your vCenter, where you're talking about shallow rekey, and this came up last night over at the Hilltop A. Yeah. So Jace touched on this a little bit, right? So if you're having issues with, so for some folks out there, right, they've used this this non-supported KMIP server, right? It's been blogged about. I think William Lamb also posted about it, right? The Python KMIP, I believe. And so if you want to move to a supported one, Jace has a really easy way of doing that, and it's by adding something like HYTRUST KMS, right? Key control in there as a second KMS, and then using a shallow rekey to make everything come over. So it's not going to be disruptive to the environment if people are needing to move from an unsupported KMIP to a supported KMIP. So there's a way of doing that. I just wanted to bring that up because we were talking about shallow rekey.
Oh, no, that's very important. It's all about the shared secret, the key. If the KMS server, new one or old one, is using all the same new key, when you move it over, it'll be pretty seamless. But if you have different keys and you're trying to move them around, it's not going to work. Yeah. So having the ability to generate new encryption keys is what's really good about that operational feature. Yeah, so encryption is all based about shared secrets and algorithms, and really hard to crack because they're really large key ciphers. So that's what's important there. But good point. Very, very valid point. And you may decide to deploy something that's non-tested, or trial something. Just it's up to you to see. It's up to you to see what's going on in regards to how you want to change your operational model. Like I said, I always in that last slide presentation here, this is what's important. Make sure your vendor you choose for your KMS is supported, and you'll see that search right there. Okay, so here's that. It's still doing its thing, but because of time, I'm going to go ahead and do one last feature. Because remember how we talked about this right here, where we have a KMS cluster? I'm going to stress this some more. Don't have just a single KMS server. Have at least two, minimum of two, three if you want to avoid split brain. Because what happens is you're going to have, it's a cluster technology, right? So your vendor should, and this is a caveat, your KMS vendor should make sure that it has advanced features for these advanced topologies, support you, and however you're laying out your business need, your infrastructure on premises or even in the cloud. So that being said, we want to go ahead and take advantage. That's doing its thing. Excuse me 1 second. You can see here's the KMS itself. If we were to log on to this IP address real quick, I wanted to demonstrate that. So we go to that IP address. And we log in. You can see this is very simple, very straightforward. Here's the cluster. I can see exactly what members are in my cluster. How's my cluster defined? I have one current node that's online. It's 99. And you can see what's going, if I look at this other node, if anything's going on here or not, what's the health, what's the key group, how you maintain it, very straightforward, very simple. And if you go back to here, you can see that I'm currently only using one. And what did I just say? We want to make sure we have a cluster for the KMS, minimum of two. So you add another KMS. We know that the other IP address is the same. So we're going to call this HT KMS of 2. You can see right here that's similar to what we did already. And then we just add the address 10.159. It's very simple. 98. The same port, 5696. This is optional, don't need to add that. Now here, Vic, I'm gonna let you.
Yeah, absolutely.
So don't do this silly mistake.
Absolutely. So here's a gotcha, right? Especially for those folks out there that are using like a password manager that's tied to either Firefox or to Chrome, if that's what you're using for your browser. So it tries to populate the password field, and when you are adding your KMS, in this case we're adding key control, which is our KMS at HYTRUST. We don't use a password of any sort when we start to do the trust between vCenter and our key control server, or KMS. We use a certificate to set that trust between the two. And so you want to ensure that any username and password fields are blank before you move forward, and, such as in this case, as Voung is about to show you.
Yeah, so what's important about that is understanding if you use a password that can be compromised. If you have a certificate that is generated from the KMS solution, you're going to have an option for expiration date. You're going to have an option to import that certificate so it's secure. It has built-in CCs, so it's checked in case there's a mistake. And those are things that a password can't give you. And I don't think it's pretty easy to memorize the cert contents of a PEM file, is it, Vic?
Exactly right. So when you do generate that PEM file, keep it in a very secure place. Okay.
So there you go. So this is what we're going to do. We're going to add the operational function. We're going to do is add another KMS. To click OK, you've identified it in your. The vCenter itself has one KMS. We're going to add another KMS that's already defined in your KMS vendor. And there you go. Give it a second. There you go. So you can see right there, that's what's going on. The certificate, everything populates itself. You can see how it's signed, it has an expiration date, etc., etc. Here's the certificate, here's the fingerprint. So you can see having a certificate is obviously a lot more powerful and more secure than just a simple password. There you go. Add it, you can see it's normal, and now you have availability of a cluster behind you. So when we go back to the managed cluster, you can still see it doing its thing. Yep. Go ahead.
So just a quick note on the cluster, right? We get this question a lot, and this is just not us, but we install as a pair a pair of key control servers, or KMS. We install that for the redundancy, right? For those reasons I listed earlier. You would never want to be in a situation with any customer, anybody in their environment where they don't have access to the KMS or to the keys. And so we install as a cluster. It's a cluster solution, and as soon as you add the second one, the first one will start to replicate over to the second one automatically. So it's in continuous sync with each other. So you don't have to put this, and this is important, you don't have to put this behind some kind of replicated technology, or any kind of disaster recovery type technology like SRM or other vendor out there, right? So you don't necessarily need to do that. It's going to be in sync with each other. So just important to note that. So a lot of people will try to put it, or a lot of folks have tried to put it in a replicated cluster data store, and that's not necessary.
So a personal question here. I guess it would be really cool to have a HYTRUST deep dive one day, but I guess the idea here is that if one of the IPs goes down, vCenter will talk to both of them, and it will subside, right? It's not like there's one highly available IP that the devices emulate, like a virtual IP.
Like a VIP. No, yeah, virtual IP, correct. And the reason the vCenter knows about it is because we added them and configured them right where Voung showed us, right, when we added the secondary node. So vCenter knows about it. It knows about the cluster, and so automatically the second one in the cluster will become the primary. At that point, the cluster is in an unhealthy mode, and right, because one of them has gone down. And let's face it, an OVA is a VM, and a VM, can become corrupt. It doesn't happen very often, not very often at all. But if it does, you have the safeguard of having a second one there that has all the information that the first one has. And yes, to answer your question, vCenter does.
Yeah, so it depends on your topology. Yeah, so it depends on your topology of how your management plane is organized and designed. If you have your KMS is going to be mission critical. If you're going to use vSAN encryption or even VM encryption, the KMS component is pretty important. The keys to the kingdom are in there. Your keys to your encryption. You need to make sure it's bulletproof. It has some high availability there. So yes, VMware provides simple one-click, but my background is operations, and I want to emphasize that you need to make sure that you're doing things that are going to be designed to help you maintain care and feed beyond day 1, beyond day 0, beyond day 2, so you can make sure that it's a easier life. Because I remember those days getting called at 2 in the morning. I don't like that, and I don't think anyone else does as well. So you want to make sure they're pretty resilient systems, whatever you choose to deploy.
Yeah. So I saw you mention.
So that's pretty much all I wanted to. Yeah, go ahead.
I saw you mention that you want to have the KMS server running separately from the vSAN data storage encrypting, probably in a management cluster. Should be backed up. Like you said, if you have a cluster, make sure you have anti-affinity rules so that they don't run on the same host. Any other gotchas? Can you take like an export of your keys and save it somewhere, I guess?
You can, right? So it has an object store, and there are ways of doing that. That would definitely take a deep dive. But with regards to because I'm thinking, I'm being a former VMware badge as well, right? This, Ariel, and being one of the cloud architects for VMware and being in that scenario with professional services. There are a lot of scenarios that come up, right? Especially with regards to how people have their environments set up. And so best practice, at least from HYTRUST perspective, is to have 2 nodes on that vCenter, but you can also put a third node on another vCenter, right? You can have it spun up somewhere else, like a site B or your recovery site, but it's configured inside the primary vCenter. So it would see 3 instead of 2. And that would be living outside. So in the case of, an outage, or you lose both of the KMS servers, you still have one on offsite somewhere that knows about the vCenter, or the vCenter knows about it.
Yeah, real disaster. Plane fell on the data center kind of scenario.
Yeah. Go ahead, Voung.
Yeah. So having those scenarios thought out, those use cases thought out, those are all valid design considerations. We want to make sure you go through that. Work with your architects that help you understand your availability requirements. Work with your BUs to make sure they understand what they need to do. And often the BUs don't need to do anything because the people designing the infrastructure is going to have that taken care of for you. It's going to be seamless in the background. And that's what you want to do. You want to be straightforward and simple. So that's why earlier we had a question about SED drives, self-encrypting drives. They're so to be honest with you, no one sells them that much. I haven't seen, in the commercial or enterprise space. I'm not talking about like military or other top secret. That's a different story. But for your mom and pop shops, your large enterprises, maintain those SED drives and the extra cost involved with them. It's a deterrent. And you can attest to that, right? Vic, you've been in a lot of environments as well. You've seen that situation.
Oh, absolutely, absolutely. So these are all, design considerations. It just depends on the design and what the customer use cases are. You put your consultant hat on and you start to determine what the use cases are, and then work around that.
Yeah, exactly. So that's it for our discussion. It's hitting the hour. I want to make sure that I've covered everything in the presentation that we intended to for the outline. Let's see here. We have this. The questions we got care of, and that's it. So thank you everyone for your time. I'm going to go through here, and that's it. You can see it's a lot going on here. You want to increase your vocabulary, get your dictionary down, and that was the presentation for today. I'm sure you'll edit some of this stuff out, Ariel, I'm sure. But if you have any questions, reach out to me via Twitter. Reach out to Vic via Twitter. You can see our handles right there. All right.
And those are much prettier pictures than the ones I had in my intro. So.
Yeah,
it's all good. It's all good.
All right.
Well, I think Voung has a fruit in front of his face in his Twitter handle.
Yeah. All right. Let me go ahead and stop it. Thank you so much,
That's
guys.
Security.
Yeah, no kidding. Thank you so much for presenting today. We really appreciate it. And thank you for giving us the contact information to continue having the conversation. All right, everybody.
Oh, one last thing.
Sure.
I just want to reiterate because we originally talked about vxRAIL and ready nodes. The vxRAIL solution is great for some people in your use case, but the technology we discussed today of VMware, supporting vSAN encryption is 100% valid for a vxRAIL. You need an external KMS, you need an external vCenter to make sure that it works correctly. So what we discussed today is applicable as well. Okay?
Sounds great. Thank you so much, guys. I will stop the recording now.